When we hear the words mathematics, the first thing that springs to mind is numbers. Numbers are the heart of mathematics, an all-pervading influence. But numbers on their own form only a tiny part of mathematics. The next leap in numerical inventions after numbers are fractions, which represented quantities that are not whole that are often used in commercial transactions. Between 400 and 1200 AD, the concept of zero was invented and accepted as denoting a number used to represent the concrete idea of nothingness. It is to be noted that mathematics utilizes symbols to represent value. Then, negative numbers were introduced, which was used to represent net or diminishing value. Then, irrational numbers were invented to represent numbers that cannot be expressed as fractions or integers, and along with it, the so-called real numbers. However, mathematics is not simply a concern of numbers. Mathematics also utilizes operations such as addition, subtraction, multiplication, and division for arithmetic operations. If you start with a number and form its square root, you get another number. The name of such object is a function. Another term with the same meaning as function is transformation, which transforms the first object into the second. Operations and functions are very similar concepts. Both of them are processes rather than things. A concept that explains the mechanisms of things is thingification of processes, the most powerful general weapons in the mathematician's armory. Mathematical things have no existence in the real world. They are abstractions, but mathematical processes are also abstractions, so processes are no less things than the things to which they are applied. For example, a number is a process that has long ago been thingified so thoroughly, and everybody thinks of it as a thing, when in fact it is a process or abstraction. However, mathematicians aren't only people who utilize the thingification of processes. Computer scientists have a useful term for things that can be built up from numbers by thingifying processes. They call them data structures. Common examples in computer science are lists or sets of numbers written in sequences, and arrays, tables of numbers with several rows and columns. Mathematicians build its basic objects of thought in a similar manner. Bertrand Russell and Alfred North Whitehead wrote an enormous 3-volume work, Principia Mathematica, which began with the simplest possible logical ingredient, the idea of a set, a collection of things which resembled a tree rooted in numbers. However, their model lacks an essential ingredient. It fails to describe how mathematical concepts interact. The ingredient that knits the landscape together is proof, which determines the route from one fact to another. Mathematical logic says that a proof is a sequence of statements, each of which either follows from previous statements. Proof must tell an interesting story, be convincing and stringent, for a single flaw may prove fatal. A famous theorem that displays the concepts of proof is the shock or ship-dock theorem, which instructs a participant to transform the word ship into the word dock by changing one letter at a time and getting a valid word at every stage.